All right, welcome, ladies and gentlemen, to our second section on Chapter 7, looking today at multiplying and dividing radical expressions. So we're going to be looking at how to combine two or more radicals together using multiplication and division, and then also going back to things we learned in the last section on how to simplify radical expressions with variables and numbers. So first of all, looking at multiplying radicals, we're going to be needing one little rule right here. And this little rule says that if you have the nth root, sorry about that. Let's see here. We got the nth root of A times the nth root of B, we get the answer of the nth root of A times B. So when we multiply two radicals that have the same index, then we can multiply the insides of those two radicals together. So we have the nth root of A times the nth root of B. We can say that is the nth root of A times B. So let's look at a couple of examples in this particular type of problem. So we're going to look at the square root of 2 times the square root of 8. And because the indices are the same, it's square root and square root, we can multiply the insides together. And we get 2 times 8. And we all know that the 2 times 8 is 16. And when we take the square root, so then we have to simplify this square root, the square root of 16 is 4. We can do this also with cube roots, or any root you would actually like to do, as long as the roots are the same, or the indexes are the same. We get 25. So if I took the cube root of negative 5 times the cube root of 25, I can rewrite this as the cube root of negative 5 times 25, which is negative 125. And we've done this a few times already. This cube root of negative 125 is negative 5. We can also do this with variables. We can say the square root of 6x to the third times the square root of 12x, let's just say x to the second here. We can rewrite this as, okay, well, we have the product because we have the same index on your root. We can multiply these together, and we get the square root of 6 times 12 is 72. X to the third times x to the second is x to the fifth. And then you have to think about how to simplify this radical. Now, you might recall from previous classes on how to take the square root of a number that is not a square. Well, you need to look for square numbers inside of 72. 72 is the same thing as 36 times 2. And I can say, well, the square root of 36 is 6, and the square root of 2 is the square root of 2. So when I take this square root here, if I simplified this, this becomes 6 on the outside because of this idea up here. The square root of 72 is 6. We still have a square root of 2 out here. And then as we did in the previous lesson, square root of x to the fifth, we ask how many times does 2, which is the index, go into 5? And we know that goes in there twice with 1 remaining, because 5 divided by 2 is 2, remainder 1. And we have our final answer. This is the simplified radical. What about something a little bit different here? If we had the cube root of 4x times the cube root of 10x to the third? Well, they have the same index, which means we can take the product of the insides and we get 40. Oops, sorry, that's supposed to be a 20 there. So this makes an 80. Couldn't do it if we didn't have the right numbers. All right, so now we get 80x to the fourth because we have x to the third times x, which gets x to the fourth. All right, so we need to take the cube root of 80. So I need to know what is a cube inside of 80. Now, from the previous lesson, I gave you a table of numbers, and some of them are good cube numbers. I know that 80 is 8 times 10, and I know that 8 is 2 to the third power. So I can rewrite this as the cube root of 8 times 10, and I know the cube root of 8 is 2, but the cube root of 10 cannot be simplified. So this cube root of 80 is a 2 on the outside. Then the cube root of x to the fourth, 3 goes into 4 one time. We have the 10 left over from the original 80, and we have 1 left over from the x's. One last little piece of information that we need to understand in this idea of multiplication. There is one thing that does not work. If I was to take the square root of -2 times the square root of 16, this does not work. This is a no can. We cannot do this. The square root of -2 is imaginary, which is non-real. Since it is non-real, it does not follow the same rules as the real numbers. Okay, so our property that we started with for the nth root is for real numbers only. So for even roots, so you cannot do this for even roots. If one of your numbers is negative, or even if 2 of your numbers are negative, cannot do that. All right, so that has taken care of the negatives. The multiplication. Let's take care of the division. Division is the same kind of idea. The property is almost exactly the same. If we were to take the nth root of a divided by the nth root of b, I can rewrite this as the nth root of a fraction. Now, we have used this property a couple times already in the previous lesson when we had the square root of fraction, where we could take the square root of the top and the bottom separately. So we can write one single root or 2 separate roots. Then we're going to simplify from there. So let's take a look at a couple of examples. If we had the cube root, holy moly, if we had the cube root of 32 over the cube root of -4. Now, because this is a cube root, it's okay to use the negative because that's a real answer. Now, I can't simplify 32 or 4, but if we were to take the cube root of that fraction, we know that 32 divided by -4 is a -8. So if we took the cube root of -8, we know that to be a nice number 2. Let's throw one example in here with some variables. If I said the square root of 243, oops, forgot the x. let's say the square root of 243x to the 5th over the square root of 27x to the 3rd. We're going to look at this as a single square root of 243x to the 5th over 27x to the 3rd. When we take the square root of this, we are going to divide here. Forgot where I was going this. 243 divided by 27 is a 9. And x to the 5th divided by x to the 3rd, you subtract exponents, so it becomes x to the 2nd. And the square root of 9 is 3. And the square root of x squared is x. And we get a very nice simple 3x in this case. All right, so the last thing that goes along with this division of radicals is rationalizing the denominator. This is something that's very important in the study of math. And what it is you're not allowed to have a radical remaining in your denominator as a final answer. And what we're going to do is we're going to multiply the numerator and the denominator by a number that will cancel out the root in the denominator. So let's take a look at what that means. If we were to take the square root of 2 divided by the square root of 3, well, if we did what we did just a minute ago and we said 2 over 3, well, that doesn't help us at all. So that's not what we want to do. We need to multiply by something that will get rid of this radical. For the most part, you're going to multiply it by itself. If you did the square root of 3 times the square root of 3, you get the square root of 9, which is 3. So that's what we need to do here. The square root of 2 times the square root of 3 becomes the square root of 6, all over the square root of 9. And so we get 6 over 3. This is completed. This has no radical in the denominator. The numerator cannot be simplified any farther, and therefore this is a completed problem. Let's look at another one, obviously. Let's take a look at the square root of x to the 3rd over the square root of 5xy. So because we have the square root of 5xy in the bottom, we're going to multiply by the square root of 5xy and the square root of 5xy in the top. When we do this to the denominator, notice that we get the square root of 5 times 5 is 25, x times x is x squared, and y times y is y squared. Then we can just take a look at this problem and say, well, the square root of 25 is 5, the square root of x squared is x, and the square root of y squared is y. Then we just need to simplify the numerator. When we multiply the numerator pieces together, we get 5 times x to the 4th times y. This can actually be simplified a little farther because the square root of x to the 4th is x to the 2nd. And the 5y cannot. And last piece in this particular case is that we have x squared over x. So one of those x's can cancel. And we get our final answer that looks like this. There are many different types of problems that we're going to come across on this type of work. The last one that I want to do here is one that involves a cube root. So if we did the cube root of 2 over the cube root of 3x, here's what you have to understand. You cannot just multiply by the cube root of 3x. Because notice what happens if you just do this. You get the cube root of 9x squared. Well, there is no cube root of 9, and the cube root of x squared doesn't simplify. So what you actually have to do is that since you need a cube, you need to actually multiply by, since you have 3 to the first power, you need 3 to the second power. And because you have x to the first, you need x to the second as well. That way you get 3 of those things to simplify. So we're going to multiply by that up here. 3 squared is 9, and x squared is x squared. Now notice what happens. We can get the cube root of 2 times 9, which is 18. And x squared is just x squared. Over. Here we get the cube root of 9 times 3 is 27. X squared times x is x to the third. And then we can simplify using our numbers and variables that we did in the previous problems. Cube root of 27 is 3, and the cube root of x cubed is x, and you are done. And we are done. So, you guys should have your assignment sheet. You guys have your next lesson, 7.2. Hope you guys learned a little bit of something, and make sure you ask me questions whenever you need. All right, I'll see you guys later.